In this video, we are going to compute standard deviation for a few data sets. We'll begin with data set 1. Here's our values. We have 3, and each of these values are what we call an x sub I. So we'll first begin by writing down our x values. We have 0, 6, and 9. Now what the mean does, the mean measures the center. So to calculate the mean, which we denote x bar because this is a sample, if you recall, x bar is the sum of the x's divided by how many we have. And in this case we have 0, a 6, and a 9, and then we divide that by 3 because it's 3 values. 0 plus 6 plus 9 is 15. 15 divided by 3 is 5. So x bar is 5. So if we think about this as a number line, this being 0, this being 5, 10, 15, and 20. 0 would have this location. 6 is a little bit more than 5. And then we have 9. So the center of this data set is about 5, according to the mean. Now the standard deviation measures the spread of this data set. Now again, we'll do 4 data sets to sort of illustrate, as you spread the points out, how does that affect the standard deviation. Our first step to computing the standard deviation is to compute what's called the deviations, and that's what this is. Deviation is just another way of saying distance from a value. So if we take a 0, which is our first x, and minus x bar, we get negative 5. So this value is 5 units to the left of the mean. The next deviation would be our x6 minus 5, which is 1, and our last one would be 9 minus 5, which is 4. Now if we were to add up these deviations, that's the notation, we would get negative 5 plus 1 plus 4, which would give us 0. This is always true for any data set. And this tells us nothing. If we were to take each deviation and square it, then we would never get 0. We'd always get a positive number. So the next step is to take each deviation and square it. So negative 5 times negative 5 is 25. 1 squared is 1 times 1, which is 1. And the last one, 4 squared, is 4 times 4, which is 16. So if we add up the sum of the deviations squared, and again we square because we don't want this to be 0, we have 25 plus 1 plus 16, and this gives us a value of 42. So the sum of the deviation squared is 42. Now if you recall, there's something called sample variance, and sample variance is denoted by s squared, and it has a formula that looks like this. It is the sum of the deviation squared, which we got in this case to be 42, divided by n minus 1. So in this case, the variance for this problem would be 42 divided by 3 minus 1, which is 2. 42 divided by 2 is 21. So the sample variance for this data set is 21. Now the units for this would be squared units because we squared each deviation. If you remember, standard deviation, which is denoted S, is the square root of the variance, S squared. So in this case, we would simply take the variance 21 and take the square root of it. Now if we round this to 2 decimal places, we would say that the standard deviation for this data set is the square root of 21, which is approximately 4.58. Now what this number tells us is the average deviation away from the center, the mean, is about 4.58. For our next data set 2, we have again 3 values, 0, 6, and 24. And if we were to put them on the number line, so we can see how this data set is different from the first one. We have a value at 0, we have a value at 6 again, but this time our last value is 24. So for these 3 values we have more spread amongst themselves, and the standard deviation is going to measure that. So we begin by listing our x's. We have 0, 6, 24. To compute x bar, we add up the 3 values, 0 plus 6 plus 24 is 30, and divide by how many we have, 3. That gives us a mean of 10. So x bar is 10. So the center, based upon the mean of this data set, is 10. Now, to compute the standard deviation, we need to compute the deviations away from the mean. So we take our x, 0 minus the mean, 10, and we get negative 10. The next deviation would be 6 minus the mean. That gives us negative 4. And the last deviation is 24 minus 10, which gives us 14. Now if we were to add up these 3 deviations, we would get 0. So we square them. So we take each deviation and square it. 10 squared is 100. The next deviation, 4 squared, is 16. And the last one, 14 squared, is 196. So if we add up these squared deviations from the mean, we get 100 plus 16 plus 196. That sum is 312. And if you recall, if we wanted to compute the variance, which is denoted S squared, we take that sum, 312, and divide it by n minus 1. In this case, that would be 3 minus 1, which is 2. We end up with 156. So our sample variance is 156. Now these units are squared, so we need to find the standard deviation, which is the square root of the variance, and that gives us the same units as the original data. So the square root of 156 for our S is approximately 12.49. So this is larger than we had on the first data set because there's more spread. And what this value is telling us is the average deviation away from the mean is 12.49, about 12.5. Thanks for watching.